So the graphs of these polynomials, we're going to look at the ones we've already done, like we've done linear graphs, we've done quadratic graphs, and we're going to expand now to talk about higher degrees. Now, first thing, we need to understand some terminology, some vocabulary. So end behavior is one of the first things we want to talk about. This is what happens as the graph goes left and right. Remember, we did a lot of work early on talking about infinity. Well, we're going to talk about as the graphs go to negative infinity and positive infinity, what's the behavior of the graph? Is it going up? Is it going down? Is it staying constant? What are we seeing on the graph? So let's do some notation here. When we talk about going to the left, so going to the left of our graph, going this way, that's going off to negative infinity. And that's in the x direction. So we're going to say as x goes to negative infinity when we're going to the left. When we're going to the right, we're going to say that as x goes that way, x is going off to positive infinity. So this arrow just means as x goes to positive infinity. So these are telling me what direction by what x is going. It's going to negative infinity when we're going left. It's going to positive infinity when we're going right. Now we do the same thing with up and down, but now we're talking about the y's. What are the y's doing? So the y's, when they go up, we say that the y goes to infinity because it's going upwards to infinity. We also, instead of y, we might put it in function notation. Say f of x goes to infinity. So these two mean the same thing. Y goes to infinity means that the function is going to infinity. So interpret those the same way. Going down means that the y is going to negative infinity. As we go downwards, that's to negative infinity for the y value. And also we might list it as an f of x. F of x goes to negative infinity. Would be a way to write that, or the same way. So let's talk about it. This is going to be a chart for what happens with our different functions. As an example, an even degree function might be if we have y equals, if we had x squared and plus 3x. Notice that's an even degree function because the largest degree is a 2. That could be a 4 also. Anything that has an even degree on it. What the graph will look like when we see this, we're used to quadratics. We're on the left side of this, it's going to go up, and the right side of it, it's going to also go up. When we have a positive leading coefficient, here it's 1. We know that that's what happens. When it's a negative leading coefficient, we know that that graph is going to open down. Now that might be as if we have, for instance, y equals, say we've got a negative 4x to the 6th plus 2. If you were to look at that graph, because it's an even degree, 6th power, the leading coefficient is negative, that means it's going to go downwards on the edges of it, okay? Now let's talk about what that means in terms of writing out our end behavior that we just talked about. So going to the left here, this means that x goes to negative infinity for this part because it's going to the left. What's happening to the y? Well, the y is going, in this case, to positive infinity when we have a positive leading coefficient. As we go to the left, the graph is going up. As we go to the right, which is x goes to infinity, the graph is also going up, so the y goes to infinity. So this is what the end behavior is of the graph. That's what we're showing right here and how we list it. Let's talk about down here with the even degree negative leading coefficient. Well, what's going to happen is as we go to the left, x goes to negative infinity still. And as x goes to the right over here, x is going to go to positive infinity. So that's what the x's are doing. What are the y's doing as we go to the left? If the leading coefficient is negative, well, since that flipped it going down, our y's are going to go to negative infinity here. And this y is also going to go to negative infinity. So they both go down with that one. Well, what happens if you have an odd degree? We've done linear equations, but this is going to be true for any odd degree. If we had something like y equals 7x to the third power minus 4x squared, that is a odd degree because the largest variable exponent is a 3, that's odd. The leading coefficient is 7, that's a positive number. And so if we have this polynomial, what happens is we have the left side going down and the right side is going up if you were to look at the graph. They're going opposite directions. And so how we list that then for this, we say as the end behavior, as x goes to negative infinity, which means to the left, the y is also going to negative infinity because it's going down. To the left and down means this behavior. What happens as we go to the right, as x goes to positive infinity in the right direction, the graph is going up. So y is going to positive infinity. So they go in opposite directions when we have an odd degree. What happens if we have a negative leading coefficient for this? Let's say we were to graph y equals, and let's say we chose, for instance, negative 6 x to the 5th power, odd degree, negative leading coefficient, plus 14x. Okay, the second term doesn't matter. It's what happens with that leading term? Leading coefficient is negative. That's what we have here. The degree is an odd number. What that tells us then is it's going to come down here. So as we go off to the left side, as x goes to negative infinity, the graph is going to go up. Y goes to infinity. As we go to the right, the graph of this thing, so as x goes to infinity, the y value is going to go to negative infinity instead. So we've got the contrast here with the odd. One goes up, one goes down, one goes up, one goes down. Whereas with the even degrees, they either both go up or they both go down. This is how we're going to label the end behavior and talk about what's happening using this notation here. All right, let's go on also and talk about, we've got what are called turning points, which we've already dealt with minimums and maximums. Okay, turning points are minimums, maximums, because as the graph goes up, if it turns from going up to going down, that would be a maximum. If it turns from going down to going up, that's a turning point, that's a minimum. So when we look at a graph, for instance, if we talk about a graph that looks like this, okay, how are these labeled? Well, this value here is a maximum, and it's the absolute maximum. So it's the min or max over the entire graph. So this would be called an absolute max. Okay, now this one down here, this point here, it's not a minimum for the entire graph because notice the graph goes past it. So we would call this a relative or local max because this would be a min or max in that neighborhood. of the graph. So just in this area, it's a minimum, but it's not a minimum over the entire graph. So this one we would list as a relative minimum. All right, now this one here, this is a max because in this neighborhood, it's the maximum value on both sides of it goes down from it, so it's the maximum there, but it's not the maximum on the entire graph. So this would be a relative max for this one. All right, this notice would be an even degreed polynomial. So because they both go down, it's an even degree polynomial as we classify it. And notice that it would have a negative leading coefficient because both sides go down. So negative leading coefficient, even degree, because both sides go down. That's how we could classify this graph if we were to look at the polynomial. All right, and let's do one last one here. If we've got this graph here, if we go like this, we've got, looks like a max here and a min here, but neither one of them are absolute because they go past it on both sides. So this would be a relative max, and this would be a relative min. These turning points, it turns from going up to going down, but it's the only in that neighborhood is it the maximum value because this goes past it. Here this is a minimum in this neighborhood, but this part of the graph goes past it. All right, now just so that we round out the information we need, since we've been dealing a lot with exponents here, I want to remind us of some of our rules for exponents. You learned these in algebra. I want to just remind us of it so that we use it when it comes up or it becomes relevant to the discussion. So and we'll do more rules for exponents later on, but a reminder of one of our rules, if you're multiplying two terms here, two x values here with exponents, remember that with multiplication, you're going to add the exponents. That's because multiplication refers to products. That's what exponents refer to as well. So we're adding more factors on. So that's why we represent it this way. So as an example, if I did x to the third times x to the fourth, notice that I should get x to the seventh, and that's because the first one is x times x times x, that's x to the third. And then the second one is 4x's. Notice that there's 3 here, 4 there. That gives me a total of 7 factors. That's why we add them, is because we just are extending out the multiplication further as part of the problem. So you add exponents. What happens when we divide? Well, division is the inverse of the multiplication. So what we're going to have as a rule is you're going to subtract the exponents when you have that. So as an example, if I did x to the fifth over x squared, x to the fifth is listing out x 5 times. There's 5 of them. X squared is listing it out twice. Now notice what happens is this x over x, this is equal to 1. This x over x is equal to 1. And so what happens is you have 1 times these 3 x's. That gives me x to the 5 minus 2, which would be x to the third. There's only 3 x's left out when the other x's, when you put them together to get x over x to get equal to 1. So we've done a lot of information in this first section about classifying polynomials, the vocabulary involved with polynomials, and also what's the vocabulary related to graphing. Some of this will be a review, like these review of some rules of exponents, but some of this information, like this end behavior here, the end behavior is probably brand new, and so it will be something that you'll have to spend some time working on to get used to. But now from this, we can classify according to degree and also to how many terms we have, our polynomials, and we can graph them, look and talk about the graphs, and then also information about how to combine them together using our rules of exponents.